Today, more science. Today we're going to talk about friction and force. Force first, because force is important. Now, force is basically, okay. First thing you have to remember about force, it always acts in a pair. Now, what basically means that there's always two forces, alright? Now, we have three scenarios. Number one, balanced, which basically means that, okay, let's see this, alright? Let's say that, there's force pushing from you and this guy, pushing from the other side of this, alright? So obviously this guy, let's say that he's pushing at the force about 50 newtons. Or Newton is basically, the unit of measurement for force. And you push back with also 50 newtons. So the net force that is pushed onto the wall is actually zero. Because you're both pushing from a different side, which counteracts each other. Because, it's like you throw a snowball hits, both will crumble. Alright? Now, second, let's say that you have something else now, okay? Now, this time you push, but this time there isn't much force on the other side. Like, let's say 50 newtons instead, and you push with 50. So basically, this will cause it to, have force, right? Because your push is stronger than the pull from the other side. Because, so yeah, that's the point. And third scenario is if you're both pulling to one side, alright? Because that will equal the force to 100. Because, one side is trying to pull it, one side is trying to push. So eventually, it's like, what's it? It's like pulling or pushing a, let's say a pillar, right? Because if you pull from the other side and then you push, more force applied to it, it will fall down to, the push side. Now that's force. Force, of course, is measured in newtons. Now, Newton is based off Isaac Newton, the guy with the apple that fell on his head. That's where the saying was, the apple didn't fall too far from the tree, alright? So, that's where it comes from. Newton is the name because, Newton invented the force, theory of force in general, right? Like, an item that is in motion stays in motion. That sort of stuff. Now let's talk about friction. Friction, it does also integrate force, but let's not talk about that. Now the easiest simplistic item of friction, you have both two hands. You rub them together. That's friction, and you also feel like it gives off heat because it does. All right. Friction gives out heat because, the more faster it gets, it keeps brushing over and over again, it will generate heat. Now, obviously, our hands, we can only do it to a certain point of heat, right? We can't go faster than that. But there's things that, you spin very, very fast and become hot. Now, let's talk about different examples of friction. There's static friction, which is friction that isn't used, right? So, let's see this. This phone is in static friction because it's standing still. It has not moved, alright? But if I push it or just pick it up slightly, I'm just stronger than the friction that is within it. Then there's fluid friction. Now, fluid friction is basically when a solid passes through a liquid. Best example, motor oil, alright? Now, okay, so let's talk about, motor oil. You pour it in and, makes the gears, go more smoothly, alright? Because, its oil is, very slick. Which also includes our third example, which is moving friction, right? Now, basically, this is when you take an object and you slide it over a smooth or slick, surface, all right? Like, for example, if I take this little slab of marble is very smooth, all right, and you just slide a piece of ice over it, well, boom, it's it's active friction, it's actively moving, all right. Now, obviously, that would work very differently with, a normal wall or asphalt because, it's not smooth or slick in any way. So, yeah, that's it. Those are 3 examples. There's a fourth one, but, I'm not going to spend my time talking like that because, you probably won't need to know. You search on Google and stuff. But, yeah, that's force and friction. So, thanks for watching my video. Hope you have a nice day. Goodbye. See you next time.